So we are going to continue our focus with multiplying a decimals and whole numbers, and then we're getting ready to move into multiplying decimals by decimals. So today we're actually going to take a look at how we multiply a decimal by a whole number. And so you'll notice that the icon that we're working with today is going to be patterns. So we're going to go back to those place value patterns to help us find our final solution. So your learning target says I can find the product of a decimal and a whole number by using the standard multiplication algorithm that we learned in topic 3 and looking at place value patterns. So when we look at place value patterns, that's going to help us determine where the best place for the decimal is going to be. It looks a little bit different when we multiply a decimal by a whole number, and we're going to use those patterns to help us determine where to place the decimal within the product. So I'm actually going to take a look at the problem that is on page 184. So if you could go ahead and turn your page, your math book to page 184. The problem that we're going to look at first is this problem where it says the ticket price to a minor league baseball game increased by 17 hundredths times last year's ticket price. If last year's price was $26, how much is the price increase? And then you'll notice right here, our little bubble. So our bubble says you can multiply 1726 by thinking about 17 times 26 and place value patterns. So the first thing we're going to do is we're going to multiply. And when I multiply, I'm going to set up the standard algorithm the way that I always set the standard algorithm. So I'm going to do 17 multiplied by 26. So I'm going to estimate first. So 17 is going to be around 20, and then 26 is going to be around 25. So when I multiply those values together, well, 2 times 25 is going to be 100. And so 2 times 25 is 100, and then I add this 0 on. So my answer is going to be somewhere around 1,000. Okay, so when I go ahead and I take a look at this, so 17 times 26, 6 times 7, I get 42. 6 times 1, I forgot to regroup the 4. 6 times 1 is going to be 6, plus 4 is going to be 10. So my first partial product is going to be 102. Now I put my placeholder, cross off the 4. Now I multiply by the 10's place value. 2 times 7 is going to be 14, so I put down the 4. I regroup the 1, and then 2 times 1 is going to be 1, plus 1 is going to be 2. So when I add those together, I'm going to get 2, 4, 3. Ooh, my estimate is very low to what my value is going to be here. And so I'm going to take a look, and I'm going to go back and I'm going to see if I can identify what my error is. So 6 times 7 is going to be 42. Put down the 2, regroup the 4. 6 times 1 is going to be 6. Plus 4 is going to be 10. That's good. 2 times 7 is 14. Put down the 1. Oh, 2 times 1 is 1. Right there. So I forgot to add my regrouping. And even then, my estimate's still low, but I was worth going back and taking that check to see what my answer is going to be. So that's a little bit more reasonable. It's okay because I did an overestimate by 20. By increasing that, it was an overestimate. It's not. It'll work for my estimate. So this is going to become 340. So my new answer is 442. So if 17 times 26 is 442. Okay, so I'm going to rewrite this. 17 times 26 is going to be equal to 442. What I want to know is 17 hundredths multiplied by 26. What is that equal to? So I'm looking at my place value patterns. So my place value patterns is I'm looking at here. So 17 and relation to 17 hundredths. To get 17, the difference between these. So I'll go back to my next place value. If I were to write 17, that's my number that I multiplied by. If I add a decimal, so I make this 1.7, 1.7 is going to be 1/10 of 17. And I'm not quite there yet, so because I need to get 2 numbers behind the decimal. So 0.17, to get 2 numbers behind the decimal, I'm going to be multiplying 17 times 1/100th. And so when I multiply 17 times 1/100th, 17 when I multiply that by 1/10, and then I multiply that by 1/100th. So I moved the decimal 2 places when I went from 17 to 1700s, because 17 is going to be 100 times as greater. And so with it being 100 times as greater, I need to put my decimal right here, 4.42. So the price increase is going to be $4.42, because that is what the 17% increase is going to be. So $4.42. So because this value, 17 hundredths, is 1/100th of 17, my answer, 442, my answer needs to be 1/100th of 442. And I got that by taking 442 and multiplying it by 1/100th, which means I move my decimal 2 places to the left. Okay, so that one, let's dig into that a little bit deeper and make it to where we really understand our answer. So let's go ahead and jump over into your guided practice. And so when we take a look at your guided practice, we are going to be looking at, I'm just going to jump straight in and I'm going to look at problem number 3. So I'm going to do a couple more examples before I go back to problems 1 and 2. Okay, so I have 9 8/10 multiplied by 2. So I'm going to go ahead and do my estimate first. So 9 8/10 multiplied by 2. Well, that's going to be 10 multiplied by 2. I'm going to get 20. So my answer should be somewhere around 20. Now I'm going to multiply like I would normally multiply. 2 times 8 is going to be 16. I'm going to regroup the 1. 2 times 9 is going to be 18. And then I'm going to add the 1, which is going to be 19. Okay, so my answer when I do, and I notice I ignored the decimal. I didn't do anything with it. I treated this as 98 multiplied by 2. Now I'm going to worry about the decimal, because now I need to figure out where I'm going to place that decimal. So I multiplied using the standard algorithm. So here's me multiplying using the standard algorithm, ignoring the decimal. And now I'm going back and I'm looking at place value patterns to determine where I want to put that decimal. So 98 multiplied by 2 is my first value. So I'm going to look at 98 and I'm going to look at 9.8. So 9.8 is 1/10 of 98. So to go from 98 to 9.8, I multiply my answer by 0.1 or 1/10, which means if I multiply here by 1/10, I need to multiply my product by 1/10. So if I do 196 and I multiply that by 1/10, I end up with 19 6/10. So that means I need to put my decimal one place behind, or I need to have one digit behind the decimal. So take a look here. Well, let's take a look at this pattern that we notice in this problem. And we'll see if this pattern shows up when we do a couple other problems. So the pattern that I'm noticing is that here, one of my products, I have one number behind the decimal, one of my factors, I have one number behind the decimal, and one of my products, I have one number behind the decimal. So let's see if that pattern shows up again in some of our other practicing that we do. So the next problem I'm going to do is I'm going to do problem number 4, where I have 67 hundredths and I multiply that by 8. So again, I'm going to do the standard algorithm, and I'm not going to worry about where to place that decimal until after, when I look at that place value patterns. So 7 times 8 is going to be 56. So I put down the 6. I regroup the 5. 8 times 6 is going to be 48, plus 5 is going to be 53. Okay, so I started off, when I multiplied, I started off by looking at 67. I want to know what's the relationship between 67 hundredths and 67. Well, here, in order to get to 67, I would need to multiply my answer by 100. So to go from 67 to 67 hundredths, I need to multiply by 1/100th. And when I do that, my decimal moves 2 places to the left. So it goes 1, 2, and I get 67 hundredths. So if I multiply 67 by 1/100th to get 67 hundredths, with 536, I need to multiply this. So I need to multiply 536 by 1/100th to get my answer of 67 multiplied by 8. So when I do that, that means my decimal is going to move 2 places to the left. So here, 67 hundredths multiplied by 8, my answer is going to be 5 and 36 hundredths. Now remember, we talked about we're looking for patterns that will help us solve this. Okay, so here I have 2 numbers behind my decimal in this factor, and here I have 2 numbers behind my product. So it seems to me the pattern that I'm noticing is that if I have 2 values behind, or whatever value I have with my decimals, the amount of numbers I have behind that decimal, so in this case 2, I need to have the same amount of numbers behind my decimal in my product. So here I had 2 values behind the decimal. So here I need to have 2 values behind the decimal. Okay, so that's the pattern that I'm noticing. Let's see if that pattern continues with our next problem. So I have 34 multiplied by 5.3. Now we talked about ignoring that decimal, so I'm going to rewrite this problem. I'm going to set up a little bit different. So I'm going to treat it as a normal multiplication problem. So I have 34 multiplied by 53. To go from 5.3 to 53, I multiplied by 10, which means to go from 53 to 5.3, I multiplied by 1/10. So they are 53 hundredths is 10 times greater, or 5 and 3/10 is 1/10 less than 53. So let's go ahead and let's multiply. So 3 times 4 is going to be 12. I'm going to put down the 2 and I'm going to regroup the 1. 3 times 3 is going to be 9, plus 1 is going to be 10. Okay, put down my placeholder, cross off my 1. Now I multiply my 10's place value. 5 times 4 is going to be 20, so I put down my 0, I regroup my 2. 5 times 3 is going to be 15, plus 2 is going to be 17. Add them together, see what I get. 2, 0, 1 and 7 is going to be 8, and 1 is going to be 1. Now I forgot a step here. My step should have been that I multiply, or I do my estimate. So I do 30 multiplied by 50, and I get 1,500. 1,500 is near 1,802. It's a reasonable answer. Okay. I'm going to come back here. And because I multiplied by 10 to get to 53, that means I need to take my answer of 1,802 and I need to divide it by 1/10 to find my answer. So I'm going to write 8102 under my original problem. And looking for that pattern, here I have 1 number behind my decimal. Well, when I multiply this by 1/10, I end up with 1 number behind my decimal as well. So my answer that I get is going to be 180 and 2/10. So 1 number behind my decimal here means I have 1 number behind my decimal there. I've now seen this 3 times, so that gives me enough indication that that's my pattern. So however many numbers I have behind my decimal here should match how many numbers I have behind my decimal in my product. Okay, so I'm going to try this next problem without doing the place value or actually showing you the place value, but having that conversation